But also, what's kind of interesting though is Galileo did all these experiments, so it's easy for me to confuse how it is that the one does all these physics experiments, but then Sir Isaac Newton, doing all the things that he does, also piggybacks on that, and he gets the credit for gravity and so on, right? Okay, but so the end solution to who invented calculus, well, they both seem to independently create a system that's called calculus, although the people that talk about that will generally say that Leibniz's formulas, or the way he like that, the symbol for function and everything came from Leibniz. Even the name calculus came from Leibniz. Sir Isaac Newton called his system fluxions. That makes sense. And if you think of it as a language, you've got like arithmetic, or mathematics, right? And then you've got geometry, algebra. I skipped algebra, right? You need algebra because algebra gives you, instead of numbers with the same verbs that connect the different kinds of formulas you do, you end up with algebra, which gives you symbols for groups of numbers like x and y, etc., sets, right? And so you end up with the same verbs, but you end up with a different noun in the language, and that is the variables, right? And then you go, to variables that you use for geometry. You've got variables that you could use for trigonometry, and then you go on to calculus, where you actually now have sets of sets. Does that make sense? So what's interesting is each of these new advances tends to use the same verbs, like add, subtract, multiply, divide, equal, right? But you add a complexity to the nouns that are being used in the language, so that you end up now with sets of sets of sets, and sets of, et cetera, right? Keep going meta, basically, with it. Does that make sense? By the way, one of the best books, I think, on Gottfried Leibniz is Russell. I have to do Bertrand first. By the way, Leibniz can be spelled with a TZ or a Z, or so. Lots of different ways of spelling Leibniz, because of the way it goes from. By the way, a lot of people refer to him as von Leibniz. He never earned that title. He was never made a noble, which is what the von means, right, in German. So let's get back to a general view of what Leibniz gives us. By the way, his books are still being translated. I give you a link to the current work being done on Leibniz in my notes if you're interested in that. But his work we could break down into a philosophy. It's a particular philosophy. One of the parts of it is the doctrine of monads. A monad, well, I'll explain that further. Pre-established harmony, the law of continuity, optimism, which we've already discussed a little bit, theodicy, which means kind of the narrative of God, if you think of it that way, the existence of God, the problem of evil, and the question of optimism. So one of the first and more important ones, especially today, is this doctrine of the monads. Monads are devoid of parts. They have no parts. They're basically the same thing as Euclid gives us when he describes points on a line, right? It has no parts. For Leibniz, if you're looking, and remember he's in a sense responding to Locke and Locke's materialism, where Locke says there's small little bits of matter that you can't chop up, right? You know, they're too, you know, they're the smallest you can get, and hard, and so they just form new things by the way they're connected with other atoms, right? Leibniz argues that the smallest possible thing can't have any parts, can't have any size. It has to be essentially a spirit. And now that sounds funny, because he's talking about spirits again, and you think, wow, that goes, you know, that's medieval almost, right? And by the way, a contemporary of Leibniz that we'll do next class is George Berkeley, he's an Irish philosopher, and they write to one another. And in fact, George Berkeley wrote and made suggestions to Leibniz regarding calculus. In fact, it's kind of funny that Sir Isaac Newton is very secretive about what he's doing, but Leibniz talks with Berkeley about a lot of his ideas, and they write back and forth. And in fact, there's some other women philosophers that write about it too. And that's kind of interesting, because some of the ideas actually seem to have originated with the letters from the women that he was corresponding with. So that's pretty interesting, actually. And of course, they never get the credit for any of this stuff. That's amazing. But a monad is simple, devoid of parts, indivisible and indestructible. Basically, they are souls instead of bodies. So what I would recommend is that this is prior to the change in our vocabulary, that when we get to Einstein, he's talking about energy and mass. Here we're still talking about matter and souls, and what I'm going to argue is that essentially they were thinking the same thing, it's just the vocabulary is different. And so what he's really, I would say today, if we updated his language, we would say he's saying their energy, which is exactly where we're at today. So he's 1698, you know, writing this stuff, and today what we think of as the standard model of matter is based on the idea of there being quarks that are, you know, energy and an arrangement, not something that's like an atom. I mean, atoms consist of particles that are made up of these quarks. So when you get right down to it, even though physical things seem very hard and physical for us, right? They're actually being made up of particles that are, you know, swimming around, basically. You know, very strange, very strange. And each monad, now this is hard, and I have no idea how to interpret this, but each monad is a microcosm or universe in miniature, a mirror of the entire universe. Can't help you there. It's what he says, but no one really seems to understand exactly what that is. Perhaps, in a sense, if you think of it in terms of the idea that every level seems to be kind of a copy of the higher level, we call it fractals. Are you familiar with fractals? Anyone? Nobody's interested in fractals. Yes? Fractals? Yeah, fractal. Yeah. So you know, to some extent, you know, it seems like everything. I especially like trees. You know, as an example of this, is when I look at a tree and I look at the leaf looks like the tree, basically. You know, and then the branch looks like the tree, a little bit bigger than the leaf, and then of course the tree looks like the tree, because it does, right? You know, it's just, you know, and you think, you know, I think birch trees have personalities.
Yeah, and they have eyes too.
They have eyes?
Yeah. Yeah. You know what kind of tree I like? I like oak trees. 'Cause they have those like beards that like moss, but it looks like beards.
The Spanish moss?
Yes, yes.
I took a some pictures of them.
I
went to
love-
Florida.
Yes, I love Florida so much for that reason.
We don't have any here though. They're hardwoods and they won't grow.
Yeah.
I think there's a hardwood tree growing just across the street from the McDonald's on Muldoon, which is kind of neat. And we have a whole bunch of trees all along Providence. If you've ever walked up towards APU, which is where I park my car.
Oh,
Oh, did I tell you my secret?
uh-huh.
Yeah.
Is it close? Like really close?
It's just a short walk. Yes? No? Depends on what you mean by close. But in any case, if you look at the trees that are there on this side of the street, as you go up there, there's 30 of them. I think maybe there's 50. But I believe they're all hardwood trees that you can tell are grafted. You know, if you look at all along the same size, about this far up from the root, you can see where the tree that's growing is different than, and they're maples. That's a hardwood tree, right? Maples? We'll go with that.
Yeah.
In other words, maples, because maples don't grow up here, but these obviously are. So I'm curious about who planted them, and they're right here for us to enjoy. You ever looking for maple leaves? You know,
That's
which
good.
Canada's famous for.
Do you think they're gonna make a maple farm? For maple syrup?
I don't, they're too young yet. If they tap them now, they'll kill them, I think. But in any case, so maybe that's what he means by a microcosm. And the uncreated monad, is God. Can't figure that one out either. So some of these are quite difficult. And best of all possible worlds. Doctrine of pre-established harmony. Everything is interrelated and everything works perfectly together for the design that the universe has. That doesn't mean we might like it. Right? That's totally divorced from our idea of what would be great for us, right? But at the same time, he's basically saying everything is interrelated, and you know, the butterfly effect. You know, the butterfly flaps its wings in the Amazon and it creates a storm in Boca Raton or something, right? Whatever. So it's all interrelated. That is all way ahead of his time. That's something that we also accept today, and we think, you know, all these systems are interrelated. So, you know, global warming is influencing this, that, the other thing, and it's all tied in to everything. So everything cooperates in the universe, not only because God is the source from whom they all spring, but still more so because God is the end towards which they are all tending, and the perfection which they are all striving to attain. So this isn't the kind of perfection that you think, you know, it's exactly, you know, perfect. No, this is perfection in a much bigger, more complex sense. And the law of continuity, no two monads can be exactly alike or they would be the same. There are no breaks in the continuity of nature, no gaps. And we can see that, you know, when you look at the cells in plants and you look at the cells in animals, you notice that the cell structure is the same, basically, isn't it? Give or take. But they have a nucleus, right? They have a membrane, you know, they have stuff in them, you know, that is, and they're porous in some respect, right? So now I've already mentioned the best of all possible worlds. God is the original infinite monad. His power, his wisdom, his goodness are infinite. Things or events are real when there is sufficient reason for their existence. Kind of interesting. He describes the difference between history and fiction. You've ever wondered what the difference is between fiction and history? Because sometimes you get historical fiction. You think, well, like if you read the book about Agnes Magnusdóttir, the one who had her head chopped off in Iceland, there's a book called